it is my pleasure to introduce Heather Himmelberger, Director at the Southwest Environmental Finance Center. Heather, I'm turning it over to you.
Well, good afternoon, everyone. It's a beautiful spring day here in Albuquerque, New Mexico, and I hope all of you are doing well. I'd like to welcome everyone to today's webinar. And as you can see on the slide that's showing on your screen right now, you can see the geographic distribution of today's attendees. We have people from all parts of the mainland as well as Alaska and Hawaii listening in today. I would like to thank the Syracuse EFC for hosting and recording today's webinar, and I'd like to thank Don Null for helping to facilitate the question and answer session. And just as a reminder, you can type in a question at any time during the webinar in the chat box using that feature, and we will answer as many as we can when we get to the end of the webinar. This webinar is part of the Environmental Finance Center Network's project called Smart Management for Small Water Systems. This project is funded by the EPA and allows us to provide managerial and financial capacity assistance to small water systems all across the country. In this context, a small water system is defined as one serving 10,000 people or fewer. We have provided a series of in-person workshops on asset management, rates and finance, energy efficiency, water loss, access to funding, and water system collaboration. Hopefully some of you were able to attend one of these in-person trainings. As a part of this project, we are also holding webinars in most of these topic areas to accommodate individuals who are not able to receive in-person training or who were interested in an additional topic besides what was offered in their area. Today's webinar is part of the Strategic Water Loss Reduction series of webinars. We had 3 in this series, and the first webinar was focused on understanding the problem. The second webinar focused on strategies to address real water losses, and this third webinar will focus on strategically applying water loss reduction strategies. Essentially, we will be talking about how you make decisions regarding which strategies to apply and how to apply them. Each webinar was designed to be a standalone webinar, and if you missed any of them and you wish to listen to one of the ones you missed, you can access the previous webinars online at efcnetwork.org. You can also access other webinars besides just the water loss. We've got all the other webinars archived as well, and you can access any of those on our website and listen to any of the other topics you would like to listen to. So with that, we're going to start with a quick review. This equation probably looks familiar to those of you who have done any water loss reduction in the past, and you'll see an equation that says water produced minus water sold equals water loss. But we need to remember that water loss in that equation is more than just water that's leaking from the system. It's really all of these things that you see on screen. Anything from water that you use within your town that's authorized but unbilled, to illegal water use, people who are stealing from your system, to water that the utility uses for flushing or other purposes, to the data handling and errors that may occur there, inaccurate meters, and then finally the lost water, which is what people have equated in the past. They've equated that number with just the water loss part, when it's really all 6 of these things. So we really want to view the equation this way, where water produced minus water sold is non-revenue water. It's water that we do not get any money for. So the way we categorize that is we do a water balance or a water audit, and AWWA has probably one of the best ways of doing this, and you can go online and use their software, their water audit software, for free. And what we're interested in the non-revenue part is looking at what are the water quantities that occur in each of these categories down here. And then specifically when we were dealing with real water loss, we're only dealing with this part of the balance. So you can see it's just one portion of the balance, and we want to see what our water loss is compared to the other categories. So before we start, we like to do a water balance and kind of figure out what is non-revenue and what is water loss from our system. So when we think of just the real water loss portion, that bottom part of the water balance that we were just looking at, we can think of our current annual real losses as being all the water in the system, the real water that's being lost to the system. And this is water that's lost from pipes, from service lines, and from storage tanks, although we're not really going to focus much on storage tanks today. But storage tanks that are overflowing all the time or leaking will also cause a water loss. So if you think about this green box sort of representing the current annual real losses of the system, there's also a smaller red box that occurs, and we call this unavoidable real losses. And unavoidable real losses is that part of the water loss that we can't really control except by changing pressure. So if you operate at a given pressure, there's a certain amount of loss that we say you just can't avoid. It's just going to happen. These are the types of losses that occur at fittings, at joints where the pipe pulls apart a little bit. Where the pipe hasn't actually broken, it's just a little bit loose and water starts dripping out. You can kind of think about it, you know, like attaching your garden hose to the hose bib in the back of your house. When you first attach it, it might be nice and tight and no water's leaking, but over the course of time, as you use the hose and turn it on and off, the pressure causes it to separate a little bit and then water starts to drip out. It's kind of the same for the pipes. It's that water that's kind of dripping out in the connections. So what we say is we can really only address in our water loss reduction strategies this area that's hatched in purple. This is the amount of water that we could actually save by doing a water loss reduction strategy. Then there's another part of our water loss that we want to think about, and that's what is economic for us to do. And this is a different level. We know that we have the potential to reduce all of this green area, or what's the difference between green and red, but it may not be economical for us to go any further than this yellow boundary. And what's economic really is very system specific. So you might have a system in which it costs a lot of money to produce the water. Maybe there's expensive treatment, or the resource is very scarce, and so the amount that it costs to produce that water is quite high. And perhaps that system doesn't have pipe that's buried very deep, or maybe it's even on dirt streets, so it doesn't cost very much to implement the strategies. In that case, the economic level of real losses may be quite high and maybe almost close to what the current annual real losses is. So in this particular system, it would be economic to address quite a bit of their losses. Another system may have very inexpensive water. Maybe they don't have to do very much treatment. Maybe they have very little equipment, so it's expensive to go employ water loss reduction strategies. So in that particular case, the economic level may not be that different from the unavoidable real losses. So it is kind of important to remember that we need to keep in mind that some of our losses at a given pressure are just not going to be able to be removed, and there's going to be a difference between all the water that potentially could be saved and that water that we feel is economic to reduce. We can also add in non-economic factors. If we really have a scarce resource, we might want to go way beyond what's economical for us to do, but we just need to recognize that we're doing that we're choosing to go beyond that level for other reasons. When we go about addressing real losses, there are 4 major strategies that we can employ to address losses, and we talked about these in webinar 2 as well. So one of the ways is to respond faster to known leaks. So a leak that you have found, either somebody has done a leak detection and told you where it was, or it's visibly leaking on the ground and you know it's there. If you can get to the leak faster, you can save money and time and water by getting that leak repaired right away. So that's one strategy we can use. Another strategy is asset management, and we'll talk about what this entails. A third strategy is pressure management, or reducing pressure. And our fourth strategy is finding our hidden leaks, proactively looking for the leaks that are not visible to us. And if you'll notice, there are 3 arrows pointing in towards the green box. That's these 3 arrows. And that signifies that any of those techniques can reduce the size of this green box. You'll notice the pressure management arrow goes both directions, because pressure is the one area that can go either way. If you reduce pressure, you will reduce your losses, but if you increase pressure, that will increase your losses. So pressure actually has both effects on the system. Now we need to strategically deploy these 4 approaches, and we need to strategically decide which of the 4 to do, and then within each of the 4 we need to decide how to strategically do them. So we really want to think long and hard about what it is we're trying to accomplish and how we're going to do it. We want to make sure that whatever approach we use matches the specific issues of the system. So this goes back to the AWWA water audit or whatever audit process you use. You want to make sure that if you're taking on a particular water loss strategy that it actually makes sense, that it matches the issues that you're having in your system. If all the real water loss is really related to overflows at a storage tank, then addressing a program or developing a program that has hidden leaks in it is really not going to be the issue. It's going to be going to the storage tank. So you want to make sure, or again, if there are more losses related to inaccurate meters than there are real water losses, that's going to be a problem. So you just want to make sure that whatever you do matches the issues of your system. You also want to make sure that it matches the capability and the equipment resources of the system. So if you don't have the equipment to look for leaks, that can be difficult. If you don't have the equipment to repair leaks, that can be a real problem. You want to make sure that the quantity of funding available for water loss reduction, that's going to impact what can be done. So you want to make sure that you know what that amount is before you start down the road to picking strategies, or if that's a flexible amount of money, you want to know what you have to do to show that you need more money for your program. You also have to take in your specific infrastructure into account so that you know what kind of infrastructure you have and what technologies and techniques will match the type of infrastructure you have. You need to think about the scarcity of your water resources. If you have a very scarce resource, you may want to go a whole lot further in water loss reduction than if your resource is very prevalent and you don't really have a problem with it. So you need to think about that too and how that might impact what you want to do. And then finally, the goals of the system need to be taken into account. So whatever it is you're deciding you want to do with your system, you want to make sure that your strategies are going to match what it is you're trying to achieve. And we'll talk a little bit later about goals and goal setting. Something you want to do when you first start the process is really gather the data to assess what the nature of your problem actually is. So again, we want the results of our water audit so we can tell what portion of that non-revenue water is related to real water leaving the system. We also want to think about how many breaks do we repair each year. So you want to ask yourself, where are those breaks occurring? What type of breaks are they? Are they breaks from degradation? Are they breaks from poor construction techniques or poor materials that were originally put in? Are they breaks related to a construction contractor hitting the pipe, which is very different than a break that's from corrosion or something else? So you want to think about what kind of breaks you actually have in your system and then what pipe type and size they're on. Is it PVC pipe that's 8 inches? Is it cast iron pipe that's 6 inches? Is it steel pipe that's 4 or 6 inches? I mean, what is it that's kind of causing your problem? And oftentimes you'll see a particular size or type that's causing the problem, or location. If you map your location of breaks similar to this map down at the bottom of the screen here, you can start to get a handle on what's actually happening in your system and really look at what's going on, and is there a certain area of the system that's having a problem? Why might that area be more of an issue? It might be soils or pressures at your operator or something else, but that gives you a lot of information to kind of start the process of deciding what it is you should be doing. Another thing you can do is do a calculation, and this would be done for you if you use the AWWA water audit method. And what you do is you divide the current annual real losses by the unavoidable real losses to find out how leaky your system is. And depending on the number you get, if you get a number of 1, it means all of your losses are background losses. And the only way you're going to be able to address that is with reducing pressure. None of the other methods will really get at that particular type of water loss. So in this particular case, you may not be able to do much of anything if your levels are that low, other than a pressure reduction strategy. If your ILI is 2 to 4, there are potentials for improvements, and you have to think about which methods or method will be the most cost-effective way to do reductions. If you get up to 4 to 8, you have very poor leakage control, and water loss reduction is going to be very cost-effective and necessary because you have quite a bit of leakage in your system. If you get over 8 with your ILI, that's an extremely inefficient use of your water resources, and this means that water loss reduction should be a very high priority activity because you're having a lot of issues with leaks from your system. So again, it kind of helps you get some idea of, you know, how bad things are at your system and what you might want to do about it. Now we're going to go through each of the 4 different types of strategies and talk a little bit about what goes into employing any of these strategies. So if you're going to try to fix your breaks faster, one of the things you need to do is collect some data to help make your case that it could be cost-effective to fix breaks sooner. So thinking about something like, what would it take to fix breaks twice as fast as we do now? So if it takes us a day to get out and respond, what if we did it in half a day? Or if it takes us 2 or 3 days, what if we did it in 1 day? So what would it take to fix breaks twice as fast? Or if that seems like that would not work, how about 1/3 as fast? So pick a number on how much faster you would like to respond to breaks and fix them. And if you watched webinar 2, you'll recall that when we looked at cutting the time of leak in half, you could save quite a bit of water if you can do that, if you can cut the amount of time in half. So if you're going to do this, you'll have to say, well, what resources would I require in order to fix breaks twice as fast? Would I need additional personnel? Would I need additional equipment? Like, do I need more backhoes or more trucks or more shovels? Or what is it that I might need if I was going to try to fix breaks faster? Would I need additional spare parts? So you kind of gather up all the things that you think you would need in order to fix breaks faster. And then you start to prepare a cost-benefit analysis. So what's the cost of water production, which actually will show up on our benefit side, which is why it's kind of separated, but what does it cost you to produce a gallon of water or 1,000 gallons of water? And then what are the costs of the extra things that you would need? So you just assess the staff, the equipment, the resources, etc. that you would need to fix breaks faster. So you need to add up the cost of all those things and then put that against the benefit. So the biggest benefit to doing it faster is the quantity of water you're going to save as a result of fixing the leak sooner. So you take that amount of water and multiply that by the cost of water production on a per 1,000 gallon basis or whatever you want to do there. And then you look, would there be any other savings that might happen because maybe you reduce catastrophic losses by getting out a bit sooner. So if, you know, waiting a long time means that in some cases you have sinkholes develop or major pipes collapse or a street caves in or something like that, if you're able to get out faster, you might prevent that kind of thing. So you could also put in the benefit of that. And then are there any social benefits to fixing the breaks sooner? Benefits to your customers, less inconvenience and that type of thing. That might be a non-economic benefit. And there may be other non-economic benefits that you want to factor in there. You can either turn those into economic benefits by saying, you know, every hour a customer is inconvenienced is so much money, or, you know, every hour less that they're inconvenienced. Or you can leave them as non-economic benefits and kind of just factor it in qualitatively. Anytime that it would cost you less to increase the response to known breaks then the benefits you will achieve, it is economic for you to go forward and increase the speed. So you can kind of make this case to your decision makers, your managers, and say, okay, as long as it's economic for us to do so, we certainly want to do it. If it's not economic right off the bat, we might want to put our non-economic benefits in there and see if that might outweigh the cost of implementing a faster response time. So this is one way you can kind of decide whether it would be worth your while to increase the speed at which you respond to known breaks. The second strategy is asset management, and we'll focus on how asset management applies to the water loss situation here. We have quite a few webinars on asset management on our website, so if you want to learn more general information about water loss, about asset management, please see our website, efcnetwork.org, and go watch some of those webinars. There's a series of 5 that walk you through the process. But when it's related to water loss, what we start with is an inventory. Where are the pipes, the valves, the hydrants, the meters that make up our system? And the best way to collect that information is in some kind of mapping. It does not need to be a GIS map like the one that's shown on the screen here. It could be anything. A hand-drawn map will work, a map that maybe you print off, a base map for free offline, Google Earth or MapQuest or somewhere else, and you draw your lines on there. But just some way to collect that information into a map is kind of the best way to inventory. Then the second thing you want to do is establish what your water loss goals are. What is it that you're trying to achieve? Do you have a specific amount of water you want the loss to be per customer or per mile of main, or what do you want to actually achieve with your water loss program? You may have several different goals, or you may have one or two goals. And you want to make sure you know the target level for each goal, because this is going to really help you later on determine what strategies you want to employ. Because if you know you have to get below a certain level of leakage, perhaps it isn't just an economic level. Maybe you're going below that. You're going to have to employ a couple of different strategies to get there. The next thing you want to do is evaluate your criticality of your pipes and the related assets like your valves and hydrants and meters. And what we do to evaluate criticality is we say, what is the probability of failure of that asset? So how likely is it that that asset will fail? And in this case, a failure would be a leak or a break in the pipe. And then what is the consequence of that failure? So if you think about your piping network, you're going to have pipes that maybe are very small diameter in a residential neighborhood. Perhaps they have shown a history of leaks, so there might be a high probability of failure, but that particular pipe would probably have a very low consequence. So that would be something that would be in this box, likely to fail but wouldn't cause a bad problem. You might have other pipe where it's very large diameter pipe carrying a lot of water. Perhaps it's a main transmission main and it's getting older. And so it has a high likelihood of failure, and it also has a high consequence of failure. And that would be your high-risk stuff. And when you know which box different pipes fall in, this helps you decide strategies in terms of both pipe repair and replacement, and also it helps you decide which techniques to use in terms of, or which pipe to look for hidden leaks and that kind of thing. So this is a nice way to kind of get a handle on what's going on in your system. And knowing the criticality of the pipe helps us decide which pipe we're going to repair versus replace. When we have pipes breaking in our system, we don't necessarily have to replace all of them. We can live with a higher level of breakage in a low criticality pipe than a higher criticality pipe. So the ones that are higher criticality, meaning they're very high risk, have a high consequence, we would probably err on the side of replacement or rehabilitation of the pipe. And the pipe that's lower criticality, we would probably do more repairs. So we can separate our pipe out because repair is going to be cheaper in most cases than replacement. And so we can kind of decide to spend more on the repair side when it's not a high consequence and more on replacement when it is. And then there's also the rehab strategies, which in pipelines would be things like lining a piece of pipe so that the pipe stays in place, but we've rehabilitated it by giving it a nice clean liner that allows the pipe to continue to function for us. And then finally, we need a funding strategy. So what funding will we need for our pipe replacement? So what level of funding would make sense for that program of whatever we're trying to do for our pipes to cover the repairs, the rehabilitation, and replacement that we're trying to accomplish? And could we phase our projects to fit within our budget? So maybe you want to do a whole bunch of pipeline one year, but you just can't get the funding. If we were able to phase that over time, that might help us fit within the available funding. And then finally, looking at, is there public support for any additional funding? Sometimes if your system is in a situation where there's a lot of breaks, there may be public support to have extra funding that's specifically targeting infrastructure replacement. So a quick example of how this works in practice is the Albuquerque-Bernalillo County Water Utility Authority. And they had an issue with steel pipes. We were looking at data for a 15-year period and found out that over that time period, there was about 5% of the system that was steel pipelines, but it was causing about 50% of the breaks on average. So from year to year, the breaks would be about half the time in steel pipelines, even though it was only 5% of the pipe they had in their system. So clearly they had a huge problem with steel pipe. And the natural response might be, we'd like to just take all the steel pipe out of the ground right now. Well, unfortunately, it was going to be somewhere on the order of about $40 million to take all the steel pipe out of the ground at once, and that just was not within the level of expenditure that they had. They were looking at maybe anywhere from $2 to $3 million a year that they could spend on small diameter steel pipe. Because you have to remember that when you're running a water or wastewater system, there's a lot of competing priorities. So if I spend money on pipe, I can't spend it on wells or treatment or pump stations or anything else. So that was the main issue, is you're always competing one thing against the other. So the budget they had was going to be $2 to $3 million, and they had to have as big an impact as they could with that amount of money. So you couldn't just start at one side of the system and kind of work across until you've replaced all the steel, because the criticality of that steel pipeline was quite different from one piece to another. So they went through a whole analysis to determine the most risky pieces of steel pipe and address that pipe first, and they were able to have a really big impact. Within a couple of years, the percentage of breaks went from 50% to 35%. So even though they only spent about $5 or $6 million in that 2-year period instead of the 40 they would have liked to have spent, they had quite a big impact because they were very strategic about which particular pieces of pipe came out of the ground. So they were taking the pieces out that had the most breaks, that were showing the worst condition, and were in high criticality areas. Our third strategy is reducing pressure. We have two things we have to think about with reducing pressure. And the first one is, do I have a problem that needs to be addressed? So in other words, how bad is the background leakage in your system? And the second, is there anything I can do about it? So you first need to know if there is a problem that needs to be addressed, and then the second thing is you need to know if you can actually fix it. So you can calculate to some extent what your background leakage is, or your unavoidable losses, and what you need to know is the length of your mains, the length of your service lines, the number of connections that you have, and the average operating pressure that you work at. And there are several online resources that will walk you through, and there's even some spreadsheets you can use that will help you calculate this particular thing. So if you calculate your unavoidable real losses and they turn out to be pretty high, you may want to address that problem through pressure management. If they turn out to be pretty low, it may not be worth it for you to have to go through the time, expense, and whatever to address it. It may be better for you to work on different real loss strategies if this is the case. So can pressure be reduced is the second part. So if we know there's an issue, suppose you have a high unavoidable real loss, the question is, can you operate the system at a different pressure to try to reduce it? Because this is really the only strategy you have. Besides replacing all the pipe in your system, this is really the big strategy you have, is pressure reduction. So what you want to know is, what is your current operating pressure? What pressure do you actually operate right now? And then what pressure is required by your state regulations? And most states do have a regulatory requirement to meet, say, 20 psi or 25 or 30 psi. So they're trying to protect the public, because you don't want to operate your pipes at too low of a pressure, or you might start sucking things into the pipe, which we don't want. We want water to be pressurized so that nothing comes in, it just flows out. And then we want to know, what pressure would our customers accept? So for example, maybe the pressure the regulations require is 30 psi, the current operating pressure is 80 psi, and our customers would be okay at 50 psi. Now that gives you some room to come down from 80 to 50, but you wouldn't necessarily want to go from 50 to 30 unless you had a big public ed campaign, because you want to make sure you stay within the range that your customers will be okay with. And then you have to say, do I have a means to control the pressure? So how would I do that? Would it take a major redesign of my system? Would I have to have brand new pumps? Or do I have zones that I can control, pressure reducing valves, or some other means that I could control the pressure fairly easily? Or do I have the ability to control pressure at night? Do I have valves that I can change automatically to go down to a lower pressure at night. Again, you would not go below the regulatory pressure, but could you drop it a little bit? Maybe during the day you're at, say, 60 psi, and at night you're at 50 or 45 or something like that. But you have to figure out whether your system even has a means to control pressure, because not every system will. And you want to make sure you don't start down this road and find out, well, I really can't control the pressure in my system right now. In that case, if unavoidable real losses are really high, you would have to think about changing the design, and is that worth it to you to have maybe the addition of pressure reducing valves or changes in pumps or that type of thing. So we have a poll question just to ask those of you who are on the webinar if you have a means to control the pressure in your system. So we have a couple different options for you. You can select, we can control pressures in zones, we can control pressures at night only, we can control pressure throughout the system, we have no means to control pressure, or we can control pressure and have used this to reduce losses. So just take a moment and see which of those you think best describes your particular situation.
We'll give it about 10 more seconds. Alrighty.
Okay, so we do have actually a few people online right now that are controlling the pressure and have used it to reduce losses. That's great. We have quite a few. Actually, the biggest response was no means to control pressure. And then the next biggest was we can control we can control pressure in zones. And so you can see for the folks that are in the yellow there that don't have any means to control pressure, pressure management is probably not one of the strategies that will be the first thing you deploy. You'll probably be in one of the other three because you don't yet have the ability to do it. And then you could maybe look at pressure management later, you know, as you got other losses reduced. If you still had an issue, you might want to go back and see what you would have to do in your system to be able to control pressure. Okay, if we can go back to the slideshow. All right. So the last part is finding hidden leaks, and this is where we're actually proactively going out and looking for those leaks that are underground in our pipes that we're not able to see because they haven't surfaced. And some people ask the question, are there really hidden leaks or is everything going to surface? And I guess, you know, everything is relative, so maybe in time, you know, 10 or 15 years later, the pipe will be so catastrophically damaged or the soil will all be eroded away so that maybe something will happen for you to find it. But do you really want to wait that long to find it? There are quite a few hidden leaks that will not surface for any length of time. We've studied a few small leaks over a long period of time, about 1.5 years, and never saw any visible signs of the leaks. So there can be hidden leaks for all kinds of reasons that will be very difficult for you to find unless you proactively go and look for them. So one of the things you need to know before you proactively look for leaks in your system is what are the parameters for your system? What do you actually have within your system? What kind of pipe and appurtenances does your system have? So how much pipe is in the system? You know, how many miles, what kind of pipe, what's the age, what's its condition, what's the type and size? And then you want to know how many contact points do you have and how far apart are they. And when we talk about contact points, we're thinking of things like hydrants, meters, and valves, where we have something that we can listen to that's attached to the main line in the system, because otherwise we can't really put a device directly on the pipe to listen for the noise, so we have to have a contact point. So we have to have something else, again, hydrants, meters, and valves, that we listen for the leak noise on those, and then the noise will be transmitted down the pipe and then to the meter, the valve, or the hydrant so that we can hear it. The closer the contact points are, the more likely you are to hear your leak noises. If you have long distances between those contact points, it can be very difficult to hear a noise that's maybe halfway between, you know, hydrants that are spread really far apart. And then thinking about your size and type of pipe, if you have very large diameter pipe, some of the strategies will not work. If you have plastic pipe, the noise does not carry as well on plastic pipe, so the contact points need to be a little closer for you to hear. So if you have situations, again, like very long runs of plastic pipe with very few contact points, it's going to be a lot more difficult for you to do active leak detection. That's why it's, or proactive leak detection, and that's why it's really important to understand the parameters of your system before you invest in technologies and approaches, because if you have a setup that isn't very conducive to that, then you're going to spend a lot of money to not achieve a whole lot. You also want to think about, what is your current situation? What's your history with visible leaks, the ones that actually surface? Do you tend to have leaks that are just bubbling up through the ground? Do you have geyser type leaks? How many leaks do you have in your system? And are they concentrated in any certain part of the system or certain pipe? Sometimes communities develop in waves. Maybe there was a big chunk of your system put in the 30s, and then there was another big chunk put in the 50s. And so you'll see the parts of your town that were put in a long time ago, the leaks may be concentrated in that particular area, or they may be concentrated in a particular type, as the example I talked about, where they were really focused on one particular pipe type that was not working well for their system. So think about what your visible history is, your visible leak history is, because that's going to give you information to go forward looking at hidden leaks. That's going to tell you a lot about the hidden leaks. So your options for looking proactively are to do an active leak survey or a passive leak survey. And in an active leak survey, we're actually having a physical person walking along the pipe, listening to contact points as they go. So they're going to listen to hydrants, valves, meters as they walk along the pipeline. You have a choice of surveying the entire system, i.e. the person walks the entire length of your system, all of your pipe. You can survey part of your system, where you've just chosen to survey one particular section of the system, or you can do a statistical sample of the entire system and then allow that to choose where you're going to focus some additional resources. So considerations in surveying the entire system, you have to think about the cost of doing the entire system, how much time that survey would take, and how much pipe you have. So if you're a small system that has very long runs of pipe, which some systems do, they don't have a very high density of housing, so even though they're a relatively small system in terms of connections or customers, they have very long runs of pipe. So the survey is going to be much more expensive if you have long runs of pipe, because that's going to be more pipe that they have to walk along. So you want to think about all those sort of cost elements. And then, will you have to do surveys at night? If you have busy roads, you may have to wait until nighttime to survey, and that might impact cost. And then you weigh those against the potential benefit. So what would be the benefit that you could achieve by doing the entire system instead of just doing a portion of the system? And if there's a real reason to have information about the whole system, you might want to do this kind of survey. But if you're not really sure that you need the information from the entire system, this might be an expensive way to go. Another one is to just survey part of the system. So can you achieve most of your benefit by just focusing on the worst part of your system? You skip your newer, better pipe, skip areas that aren't conducive to surveys, like long runs of plastic pipe, for example, and you have the potential for a huge cost savings. So for example, if you were in Albuquerque, if you focused on the older sections of town and the places where the old steel pipe was, you would find most of your leaks rather than having to do all the newer plastic pipes. So look at your particular system and say, well, what are my newer areas? Where are my better performing pipe? And actually sometimes it's not always related to age, because sometimes the old cast iron pipe is doing quite well because it was so thick. So try to really focus in on where am I likely to have breaks, and again use that visual leak data to tell you, the visible leaks, to tell you where you're likely to have a hidden leak problem, and focus your survey on those places, because maybe you'll find 60, 70, 80% of your leaks by looking at maybe 20, 30% of your system. So you have the potential for lots of benefit at a much reduced cost. You can also do a statistical sample of your system when you don't know much about your pipes or where the problems will be. It'll be less expensive than a total survey, but it might be more expensive than a partial survey because you'll go through the whole system sampling different types of pipe in different areas, trying to determine where the problem areas are, and then you go back and do a very targeted survey on those pieces of pipe that are the biggest problem. You can either use a contractor to do this for you or you can do it in-house. Either way will work, but you have to ask yourself, do you have staff members who could be trained to do it, and how often would they actually be doing leak detection work? Because if it's only going to be once every couple of years, they won't remember from time to time what they learned, or a person may leave before they ever get to do it again. So you'll spend a bunch of money training somebody up, and they won't ever get to use the technology enough to get really proficient with it. And then can you afford to buy all the equipment that you would need to be able to do an in-house survey? And then you can weigh that against the cost of a contractor. A contractor on a per mile basis would be more expensive, but that would be offset by the cost of training your staff and buying the equipment. So it depends on how often you want to do it, but if you're only going to do it once every couple of years or even once a year, you probably don't want to invest in your own staff. You'd probably use a contractor. For passive surveys, you can do full permanent deployment, lift and shift, partial permanent, or partial permanent with lift and shift. So in this case, we're talking about adding a device to your system, permanently attaching it to, or I don't mean permanent in the sense you can't take it off, but meaning that you're going to leave it there for an extended period of time, like maybe months to years. So you'll have a device either on meters or valves. You typically wouldn't put this kind on a hydrant because somebody could walk away with it. And if you were going to do this, you would have to have quite a few devices. They would have to be connected to your contact points. And it would be very expensive for you to buy all these devices to cover your whole system. And it depends on the actual device you use and how, what technology it deploys. But it could be quite expensive if you have a lot of valves to put them on. Another option is to buy less equipment and do it in a lift and shift mode where you take a few devices, you deploy them for a short period of time, maybe a week, 2 weeks. You put them out on the valves and meters and let them listen, see if they hear any leak noises, and then you go around, check out the leak noises, see if there's any leaks. And then after you've done that area, you move those devices to another area, and you can keep moving them throughout the whole system. So it's a lot cheaper to obtain these devices because you need a lot fewer, but there is a time element required because you're going to have to lift and shift these devices. You can also do a partial permanent deployment. We talked about the criticality of the pipes. You might want to deploy devices on just your critical pipes. Or pipes that are hard to survey because of traffic or some other reasons, and you could permanently put devices there so they're not on the entire system, but they're strategically placed on portions of the system. And this would cost less than a full deployment, but probably more than a lift and shift. You can do the two sort of in combination where you have some devices permanently deployed and then you have another set that you lift and shift. So it might be more expensive than the other partial options, but it could give you a lot of really good information and will allow you to kind of do the whole system. So when we think of active versus passive, using a person versus devices, you have to weigh the cost of devices for deployment out in the system and for your staff to use. How do those costs compare? Do you need nighttime surveys, which the passive devices are much better for nighttime surveys than people? How many contact points? What quantity of water loss do you actually have? How often do you want to survey the system? And you really need to think about all of these issues when you decide whether you want to deploy devices or people. Active leak detection oftentimes can find more service and hydrant leaks, but may miss some mainline leaks due to the fact that they're out, if they're out during the day instead of night, it might be hard to hear. And passive is kind of can find a lot of mainline leaks, but sometimes misses the service and hydrant leaks, depending on where you deploy them, whether they're on valves or meters. And false positives can be a real issue because remember, the devices are listening for noise. They're not always able to tell whether it's actually a leak or not. So sometimes they go into alarm mode when it's not a leak, and we call those false positives, and you have to actually go out and check each one of those to see if there's a leak, and that can get very time consuming. We did some head-to-head work where we went through some same areas, and we did an active leak detection, passive with devices that are typically permanently deployed, and then we also used passive where they were lifted and shifted. And I have to say that all three gave fairly different results. They all three found leaks, but they seemed to find different leaks. We found more hydrant and service leaks with the active. We found more mainline leaks with this particular version of passive. And then we found both hydrant, service, and mainline leaks with this device, but these two options had a fair number of false positives, much more so than the active leak detection. So there really wasn't a clear-cut case of one found so many more than the others. It was just kind of what they were finding and what the process it took to find them. So I guess that's a way of saying it's really very system-specific what you want to do. There's not really a clear-cut case that this is the best way to go. So the bottom line on looking proactively for leaks, only look for what you can actually fix, because remember, finding a leak is not going to save you water, fixing the leak will. So make sure you keep looking for leaks matching what you can actually fix. Match the technology or technique to your system specifics. If you have long runs of plastic pipe with very few contact points, buying a lot of expensive technology to deploy on the valves is not going to help you much. Choose the activities that will meet the goals that you've set for your system, and then finally match your activities to the budget. So if you only have a few $1,000s to spend, you've got to be very judicious of how you spend it. If you have more money, you can do more. If you have less money, you have to be really, really careful about how you deploy the leak detection techniques. So another poll question for you, what type of leak detection have you tried? So in this particular one, you can select all the answers that apply to your system. So you've done active leak detection with your staff, active leak detection with a contractor, passive leak detection with full deployment, passive leak detection with lift and shift, or partial deployment is what that's supposed to say, or have not used leak detection at all. So just take a moment and click the ones that apply to your particular system.
We'll give it maybe about 10 more seconds.
So we have quite a few who have done kind of a mix of leak detection with their own staff and not used leak detection at all. And some have had a contractor. A few have actually used some passive leak detection. So we kind of have the range of things. And hopefully you've been able to have good results with your proactive leak detection. Okay, if we can go back to the so there are some difficulties with implementing a water loss reduction program, and by a program I mean strategically choosing between the four options, what you're going to do and how you're going to do it. There are some difficulties when you go to implement a program like that. And one of the basic ones is it's much more interesting to design and build something than to fix underground pipes. So this program is not a sexy program. There's not a lot of ribbon cutting. So sometimes people kind of lose interest in the program because it's not visible, it's not in the forefront. It's extremely important, or it can be extremely important to a system, but it's not the kind of thing that's sort of front and center in people's minds. So that can make implementation difficult. You don't want to select your program based on a preconceived notion about what's going on. You want to use the actual data from your audit or system records. You don't want to just assume that you know what the problem is. You want to really use the information you have to make the best decisions about what to do. You don't want to underestimate the time, resources, and difficulties of implementing, because it is a big process. It will take time to work through it. You don't want to do a partial implementation, because then you can't meet your goals and you can't get the work done. And finally, sometimes it fails because people fail to mobilize all the resources. You're going to need people, you're going to need equipment, you're going to need money to do a program like this, and you're going to need data. So if you don't put all the effort into it, it's not going to work for you. So kind of keep that in mind, that it will take you some time and effort to implement a program like this. So finishing up our webinar, just a few words about what you might do at your own facility. So you might want to develop a team to help you with this process. Complete your AWWA water audit or some other water audit process. Determine how large of a problem you actually have with real water loss. Before you go down the path with any of the strategies, you really want to make sure you know if this is a real issue for you or not. Examine each of the 4 methods of reducing real loss and then see if it makes sense for you to fix breaks more quickly, like the cost-benefit ratio. Does that favor fixing breaks more quickly? Using asset management to create a plan for strategic pipe replacement to be able, again, to save yourself money and get a big benefit for what you're doing. Determine whether you can reduce pressure. Can you do that all the time, at night, in various zones? What are your possibilities of reducing pressure? Can that be done? Do you have some room to reduce before you get into trouble with what your customers would want or regulatory? And then finally, look for hidden leaks. If the ILI, remember that's the infrastructure leakage level or leakage indicator, and past experience makes sense. So you want to make sure that what you do there will match the specifics of the system, because it is very system specific whether you should use one approach or another. It really isn't a clear-cut case of across the board, this is what you should do. As follow-up, we'll contact the attendees with answers to webinar questions from all 3 webinars. We've sort of saved them to the end. So anybody who's attended webinar 1, 2, or 3 will receive the answers to the questions from the first 3. We'll also give you some access to resources for water loss. And then you can contact us if you have specific assistance with water loss that you need, or questions, about your system. Feel free to contact us with those questions, and we'll follow up with you after the webinar. Just a plug for a couple of upcoming webinars. We have a regionalization webinar that will happen on the 9th of April, and then we have a special webinar that's going to take place on the 23rd of April, where we're calling it our Ask the Expert webinar. This is based on asset management, and we have a premier asset manager from New Zealand who will be visiting our center, and we're going to put him on a webinar and allow people to ask whatever questions they have of Ross, and you can pose your questions and hear an answer from one of the world's most premier asset managers. You can register for either of those by going to the efcnetwork.org website. We want to thank EPA for providing funding for this to allow us to do this project and put on these webinars. And I will have our contact information up there while we see if we have any questions to answer for the last few minutes of our webinar.
We have several questions. It says that the DEP requires backflow connections on hose bibs. These tend to burp or leak on demand. How can we minimize these leaks?
Well, that's one I guess I'll have to say that I need to dig into. I'm more familiar with the actual pipe in the street than I am with the hose bib connections, but we will get back to you on that one because I don't actually know an answer off the top of my head on that one.
And we have another question. Compared to real water loss, how do you think old, bad customer meters compare as a loss in water and revenue?
If you have meters that you have not calibrated for a long time, it's going to be a big issue because you're losing the revenue. In the one case, you're losing the water. In the other case, you're losing the revenue. If you have not checked your meters for a while, I highly recommend you see if you can get those meters checked. And some of the rural water associations have equipment that they can go out with you and test a few meters. Sometimes you have to hire a company to do that for you, but if you have not calibrated meters or checked meters in quite a while, like let's say more than, say, 15 or 20 years, you may have lots of meters that are reading very slow and you're not getting the revenue. So before you invest a lot of money excuse me, in real water loss reduction, you would want to look at your paper losses, see if you can get the revenue up, and then maybe for a few years, you could get them to dedicate that revenue towards your water loss reduction program. So you might say, okay, any revenue that we get in based on, you know, fixing our meters or doing something with our meters is money that we will put towards the water loss reduction program for, say, you know, a 5-year period or something like that, so that it might be a way to allow you to start with the paper losses and then move into some real water loss reduction strategies. But also your AWWA audit ought to help you decide how big one problem is versus another.
If I missed part 2, can I view it?
Yes, absolutely. You can go to efcnetwork.org and you can look for in the past trainings, and you will be able to find a link to the webinar too. So you absolutely can go back and listen. And I believe we'll send you links when we send out the information after this webinar. We'll send you links to get, you know, easy access to the prior 2 webinars.
And then we have a couple of similar questions about the AWWA audit software, about calculating the UARL, and it says that they're receiving errors. Says, I have completed the AWWA water audit program and received a notice that the UARL could not be calculated as either average pressure, number of connections, or length of main is too small. How do small systems get accurate UARL results using the AWWA program if that is a problem? And then a very similar question, in doing the AWWA audit, it will not give me a UARL due to the average pressure, length, or number of connections. Main is too small.
Yeah, the equation that the AWWA program is using has been checked for larger numbers of connections, longer lengths of main, and a certain operating pressure. And so the AWWA software may kick you out if you fall below those parameters. You can still use the equation. It's just not, shall we say, guaranteed, if you will, that answer is completely accurate if you fall below those. But there are other places, and we'll try to find a link to one of the other places you can go to get that calculation, and at least you can try it out. It may not be as accurate for small systems as it is for large, but it's something that you could still calculate and at least have some idea of your UARL. Because I think the way the AWWA software is set up is it kind of keeps you within those strict parameters, but there are other places where you can go and maybe put in those parameters and at least get some idea. It hasn't been studied as much for smaller systems as it has for larger systems, partially because it's been done overseas where the systems tend to be larger, and they've put a little more effort into figuring out the equation for the UARL, and we have not studied quite as much, you know, the impact of, you know, having smaller systems and how they calculate that.
All right, we have a couple of other questions that came in. I think that we probably don't have time to answer them right now, but we will put out a list of question and answers. So if we didn't get to answer your question today, keep an eye out for an email that will be coming that will have a link to all of the questions that we've received and all of the answers that we have given to those questions. And also, I just wanted to give a quick reminder, in the chat box is a link to a survey evaluation for today's webinar. It's very brief, but we would very much appreciate your feedback on the webinar. So if you would please take the time to click that link and complete our survey.
I'd like to thank you all for attending today. And again, you know, anybody who wants to catch up on prior webinars of this topic or any others, you know, please visit efcnetwork.org. And I wish you all a good rest of your Monday.